In our previous video, we dealt with how to divide surds, and we applied the law that root AB, root A divided by B is equals to root A divided by root B. Likewise, we apply the multiplication law that says root AB is equals to root A multiplied by root B. Now we have two questions here. You can as well pause the video and give it a try on your own, and then we solve together now. So to simplify the first question, we say 5 root 7 is multiplied by 2 root 3 divided by root 45 multiplied by root 21. Yes, like I said earlier, the best thing while performing simplification with surds, operations of surds, is to reduce each and every term to its basic form. So we can see 5 root 7 is already in its basic form, 2 root 3 likewise is in the basic form, so we have to convert root 21 and root 45 to its basic form. So 5 root 7 multiplied by 2 root 3 divided by root 45 can be said as 4, 9 multiplied by 5, and root 21 can be said as there's no really basic form for root 21, so we can just say that instead of writing 21, we write it to give us root 7 multiplied by 3. Okay, and we can choose to leave it at that. I will show you why. So to do this further now, and let's leave it at that, root 21, and we'll perform another operation to show you how to split it again. So let's perform the numerator multiplication. So this will be 5 times 2 multiplied by root 7 multiplied by root 3, and the denominator will be root 9 multiplied by root 5 multiplied by root 21. So this will give us 10 multiplied by root 7 multiplied by root 3 divided by 3, because root 9 is 3, multiplied by root 5 multiplied by root 21. Now when we perform root 7 multiplied by root 3, let's apply the multiplication law of surds, and then this will give us 10 multiplied by 7 multiplied by 3 divided by 3 times root 5 multiplied by root 21. So 10 multiplied by root 21 divided by 3 root 5 multiplied by 21. Now we can see root 21 at the numerator. We can also see root 21 at the denominator. So they nullify each other, and we will be left with 10 divided by 3 root 5. So before I continue, let me show you why I was contemplating on making this root 21. So in the same vein, we can have 5 root 7 multiplied by 2 root 3 divided by root 9 multiplied by root 5 multiplied by root 7 times 3. Now if we split the surds, we have 5 root 7 multiplied by 2 multiplied by root 3, and this will give me root 9 multiplied by root 5 multiplied by root 7 multiplied by root 3. Of course, we are going to arrive at the same answer, but through a different way. So root 7 here, we will nullify root 7 here. Root 3 here will also nullify root 3 here. So we'll be left with 5 multiplied by 2 divided by root 9 multiplied by root 5. So this will be 10. Root 9 is 3 root 5. So whichever way you choose, you will still arrive at the end. So now we can see that this is not yet the final answer, because we have a surd expression at the denominator. That's root 5. We also have root 5. So what we are going to do now is to rationalize the denominator. So we continue with this, and to rationalize the denominator, we multiply the numerator and denominator by the denominator. So this will be gives 3 root 5. So this will be 10 multiplied by 3 root 5 and 3 root 5 multiplied by 3 root 5. So this will be 30 root 5 divided by 3 times 3 multiplied by 3 multiplied by root 5 multiplied by root 5. So this will give us 30 root 5 divided by 9 multiplied by 5. So when we simplify this further now, this will be 30 divided by 45 root 5, and this can be simplified further to give us 2 root 5 divided by 30 by 3 rather, because we are dividing 2 by 15. All right, so this is our final answer, and this is acceptable because the denominator doesn't have a surd expression. So now let's look at the second question. We have root 18 multiplied by root 20 multiplied by root 24 divided by root 8 multiplied by root 30. Now, how do we go about this now? So, since we are going to a final answer, we cannot split them into all forms of multiples. So this will be 6 times 3 root 18. 20 can be written as 10 multiplied by 2. Root 84, okay, can be written as, it depends on how you picture the solution in your mind. So this is just where I pictured the solution in my hand. So this will be root 8 multiplied by 3, and root 8 will still remain root 8. Root 30 in this case now will be root 10 multiplied by 3. Now we can go ahead and make it multiples of roots. So this will be root 6 multiplied by root 3. That means we're applying the law of multiplication of surds. Okay, and the law states that root AB is equals to root A multiplied by root B. So after we've done that, we'll see which can nullify and which cannot, and then we'll simplify the rest. So this will be root 8 multiplied by root 10 multiplied by root 3. Now 8 will be nullified by 8, root 8 will be multiplied by 8, root 10 will be multiplied by root 10, and likewise root 3 will be nullified by root 3. So we'll be left with root 6 multiplied by root 3 multiplied by root 2. Now we'll just combine them all together, and this will be 6 multiplied by 3 multiplied by 2, because the multiplication rule of surds can also be extended to 3 terms. So we have root ABC, and this will be root A multiplied by root B multiplied by root C. Okay, just like we just have here. Therefore, this will give us root 6 times 3 times 2 is root 36, and the square root of 36 is 6. Now that we have completed addition of surds, multiplication of surds, and division of surds, now in the next set of videos, we will be looking at a new dimension of surds, whereby though we have been dealing with, let's say, root A, B, or let's say format of surds of root A root B, or let's say root C. Now what happens when we have surds in brackets? So we have A plus root B, in the sense of A plus B root C and the likes, and or we have root A plus root B. So this is what we call surds in brackets. So in our next set of videos, we'll be dealing with operations in surds in brackets, multiplication, division, and we'll also deal with the rationalization of denominator there.